Good afternoon and welcome to today's presentation, Litigation of Building Defects, Energy Costs, Health, Safety, and Comfort, Part 1. In today's webinar, Mr. Donald Wulfinghoff will discuss the main points, what's at stake, categories of damages, and who is harmed. To give you a little background about our presenter, Donald Wulfinghoff, he's a professional engineer. He has been a licensed building engineer, a commercial broadcast engineer, and a certified automotive mechanic. Don has investigated and testified in cases related to shipbuilding, automotive accidents, and energy systems. He has been improving the quality of buildings since 1974 and is the author of 2 revolutionary books on building design and operation. Congressman Roscoe Bartlett, the renowned sustainability sage, described him as the world's leading expert on energy efficiency in buildings. Attendees who require a passcode, the word for today is litigation. During the Q&A session, we ask that you enter this passcode into the Q&A widget for CLE reporting purposes. The Q&A is located to the left of your screen. Please remember that if you are applying for CLE credit, you must log onto your computer as yourself and stay for the full 60 minutes. You are also required to complete the survey at the end of the program. Please note that CLE credit cannot be given to those watching together on a single computer. Tomorrow morning, we will send out an email with the link to the archive recording of the webinar. The slides can be downloaded from the resources list to the left of your screen. Thank you all for attending today, and Don, the presentation is now turned over to you.
Well, hello, everyone. I am indeed Don Wulfinghoff, the disembodied voice with whom you'll be communicating for the next hour. During this talk, even though we can't see each other, I'll try to visualize you and your interests and your needs as attorneys. And I look forward to hearing from you during the discussion breaks. And, of course, TASA will put you in touch with me if I can help you with your litigation activities. This is what we're going to talk about today: buildings. The design of buildings, the construction of buildings, and the operation of buildings, both commercial and residential buildings. Buildings are expensive to build and they're expensive to operate. They dominate the lives of those who live and work in them, and this discussion focuses on aspects of buildings that commonly cause serious damages to building owners, to occupants, and sometimes to others. The specific damages that we will cover include excessive costs for energy and energy systems, diseases contracted in buildings, discomfort, loss of productivity, and physical safety hazards. Now, why do we cover these particular types of damages together? Because they're interrelated. They typically have common origins in the energy design and the energy systems of buildings. In fact, we could call this group of damages energy-related damages. However, that would fail to convey the damages in health, safety, comfort, and productivity. These damages often are the result of incompetence by licensed professionals, willful negligence, and reckless disregard of the welfare of the client and of society. This area of litigation is relatively new, and it is largely unsettled. Damages often are unrecognized, and they're generally under-litigated. As a result, this area of damages calls for better understanding by attorneys, along with creative legal thinking. By the same token, you don't have to be a specialist in construction or construction law to prevail in this field. Everyone's a pioneer. This discussion will not cover the kinds of building failures that have grabbed headlines in the past, such as structural collapse and fire. Today, such failures are already covered by well-defined legal approaches and well-established availability of experts. Instead, what we'll be doing in these 2 sessions, today and Thursday, is pioneering. Here's the disclaimer that I make when speaking or writing about topics that touch on legal issues. I am a technical expert, not an attorney. This presentation is made from the standpoint of an expert who has worked with attorneys in a wide variety of cases. And the purpose of this presentation is to summarize lessons that involve technical expertise in this particular area of emerging litigation. This is a big topic in both subject matter and damages, so we'll be presenting it in 2 parts, again, today and Thursday. This is the outline of our 2 sessions. Today we'll cover the main points of this area of litigation, what's at stake in the way of damages, the nature of the damages that you'll be dealing with, and who is harmed, which generally means who are the potential plaintiffs. In the second session on Thursday, we'll cover who's at fault, which is to say who are the likely defendants, challenges of this particular area of litigation, how to select your experts, and we'll conclude with comments and recommendations. Let's begin with the main points. Defects in design and construction are endemic in the building sector. They're everywhere. Building defects often have shared causes, and they often occur together. Victims may be unaware of their damages, or they may not know how to achieve redress. It's especially important for the attorney to understand that the client's initial complaint may be just the tip of an iceberg of more extensive damages. Legal questions may be unresolved, which invites creative legal thinking, and finding effective experts is challenging for a variety of reasons, but they can be found. Okay, next, let's look at what's at stake. The U.S. building sector spends more than $400 billion per year for energy. A large fraction of this energy is wasted by defective design, construction, and operation. How much of this is wasted, we don't know precisely, but it's a large fraction of that amount, perhaps more than half. Defects that waste energy also cause damages in health, safety, productivity, and comfort. Damages in these areas may greatly exceed energy costs, so we're looking at more billions of dollars. And the sale and rental value of a facility are harmed by excessive energy costs and by those habitability problems. Now we'll spend some time discussing the issue that requires the greatest amount of thought and effort in making the case, which is the nature of the damages. An assertion of damages is what triggers litigation. So the attorney needs to understand which damages occurred, how they occurred, and why they occurred. This will be the longest part of our discussion because damages that occur in the building sector are numerous and diverse. These are the specific damages that may occur in this area of litigation: excessive energy costs, health hazards, discomfort and impaired productivity, wasted capital expenditures, incorrect energy billings, latent physical hazards, and devaluation of the property. We'll cover each one of these individually. A fundamental point is that the client, at the time he first approaches the attorney, probably does not have a clear picture of the nature and extent of the damages that he is suffering. The client who seeks redress for one type of damages may also have suffered others. For example, if the occupants are complaining to the owner about discomfort, it is likely that the building also has excessive energy costs and that it may be creating health hazards. It's up to the attorney and his experts to enumerate all the damages that may have occurred. So let me recommend that you use this slide as a checklist for that purpose. One reason for under-litigation of building defects is that these damages tend to be invisible, or they're not recognized, or defective conditions may be considered to be normal. For example, occupants who suffer from the heat and glare of working near the glass facade of a modern office building may believe that these conditions are normal and unavoidable, whereas in fact, they're signs of incompetent or heedless design. The attorney has to make the invisible or vaguely felt damages both visible and compelling. And the attorney has to make the case that bad building conditions are not normal and not acceptable. The first type of damages that we discuss is excessive energy costs. We start here for several reasons. First, many buildings, perhaps most, are costing their owners much more for energy than they should be. Energy waste in buildings is everywhere. Walk on the streets of any city and look around, and you will be looking at millions of dollars of energy waste per year. The second reason that we begin with excessive energy costs is that they are commonly the most tangible of damages, which is to say the damages can be documented concretely, which is, of course, a great aid in litigation. The third reason is that wasted energy costs may account for the largest dollar amounts of damages, and fourth, energy waste commonly indicates that there are other problems in the building. However, excessive energy costs also are commonly the least perceived of damages. In most commercial building management, the energy bills are passed automatically to the accounting department, who pay them without questioning the amounts. In fact, energy cost has been a blind spot of building management until recently. The magnitude of energy costs rarely receives as much management scrutiny as other operating costs that may actually be much lower, such as cleaning and equipment maintenance. This makes excessive energy costs a sleeping giant of litigation. Once building owners become aware of their energy costs and the fact that they are excessive, we can expect a surge of new litigation. Energy waste varies considerably by the type of building. An office building with a glass curtain wall is likely to waste much more energy than a big box store. That won't always be true, but that's a fairly reliable generalization. Energy waste also varies widely within each building type. During the late 1970s, I was part of a group of volunteer engineers who made one of the first surveys to understand the energy consumption patterns of buildings. What I discovered at that time I came to call the rule of 5, which is that within any category of similar buildings, the energy consumption per square foot varied by a factor of 5, from the least expensive to the most expensive. For example, we examined 2 similar office buildings in Houston, Texas, which are across the street from each other. Both are 20 stories tall. Both have about the same rentable area. Both have cafeterias. Both were designed in the 1960s. Both are owned and operated by the same company. We discovered that the energy consumption of one of these 2 buildings was several times greater than the energy consumption of the other, which was an amazing difference at the time. Unfortunately, it can be expensive and time-consuming to establish how much of a building's energy costs are excessive. This is because energy waste is distributed throughout a building. The energy audits of buildings that we performed since the late 1970s have shown that dozens or hundreds of instances of energy waste cumulatively occur in a single building. Therefore, establishing the full extent of wasted energy cost requires a comprehensive examination of the building design and the physical building itself. Let's summarize the leading causes of excessive energy costs so that you can look for them when a client comes to you seeking redress. A dominant cause of energy waste in many commercial buildings is architectural design that is heedless of energy efficiency. The most visible example is the extravagant use of glass, which has proliferated in the past few decades, wasting enormous amounts of heating energy in winter and enormous amounts of cooling energy in summer. Let me explain why I choose the word heedless. It implies that the responsible party is aware that he is supposed to be doing something or that he's doing something wrong. At least he's aware in some inchoate manner. But that individual makes a conscious decision to ignore what's going on. This is a problem that is endemic among architects when dealing with energy costs. Incompetent or obsolete HVAC design, and I'll keep saying HVAC, which means heating, ventilation, and air conditioning, which is a term of art in the building business. Incompetent or obsolete HVAC design is also a prime cause of excessive energy costs. The best current thinking about HVAC design is not being widely adopted among engineers. In particular, centralized ducted systems are wasteful, and they're responsible for health hazards and other problems. And responsible engineers know how to avoid them, but ducted systems still prevail. Lack of coordination among the designers is another prevalent cause. Good building design requires close coordination among all the designers, but as a generality, that's not happening. A classic example is architectural design that fails to adequately accommodate the HVAC design. Builder incompetence and error is another common cause of energy waste. Many types of skills are needed in commercial construction, and the average skill level is pretty high. But there are exceptions. For example, insulation commonly is installed in a manner that undercuts its effectiveness, sometimes very severely. Inefficient equipment wastes energy. There are now minimum standards for many types of building equipment, but the minimum may not be the most advantageous for the owner. It's the responsibility of the designers to specify the most cost-effective level of efficiency. For example, cooling systems now have SEER ratings that exceed 20. SEER, by the way, means seasonal energy efficiency rating, and 20 is a number that is directly proportional to the efficiency of the system. But equipment with SEER ratings as low as 10 is still being installed. In other words, the air conditioning could be using twice as much energy as it should be if the designers had selected the equipment properly. Sometimes equipment is defective. For example, some heat pumps and air conditioners have cooling coils that don't drain properly, leading to inefficient operation as well as discomfort, mildew problems, and other problems. Failure to check out the operation of a building upon completion is a continuing problem, as we'll discuss in the second session on Thursday. Commercial buildings are complex, and most of them are custom designed. Therefore, they will have a certain number of birth defects that need to be corrected. Careless energy purchasing can waste money to the extent that options exist, and we'll discuss that issue further. Improper operation by the facility staff can waste energy and cause other problems. For example, leaving the lights on all night after the cleaning crew leaves can double the lighting energy consumption of a building. And tenant behavior can waste energy, such as leaving windows and doors open when heating and cooling are required. We're able to document where the energy costs in buildings are excessive, but the essential legal question is the extent to which anyone is liable for that excess. The answer may depend on history. Liability may depend on when the design originated, when the building was built, and when later equipment was installed, and what the designers, builders, and equipment manufacturers knew at the time. Energy costs and energy efficiency erupted for the first time as a major issue in 1973 as a result of the energy shortages that came out of nowhere as a result of the Arab oil embargoes. In the period immediately following the energy crisis of 1973, a subgroup of HVAC engineers took aggressive action to improve energy efficiency in building design across the board, not just in HVAC. But even after the 1970s and continuing to this day, there continues to be reckless disregard of efficiency. Studies are showing that our newest commercial buildings are about as wasteful as older buildings. There's been no progress in net energy efficiency, although the reasons have changed over time. Building designers are still skirting the issue of energy efficiency for reasons that we'll discuss in the second session. To satisfy an owner's desire for low energy costs, designers may make claims of energy efficiency that are greatly exaggerated or that may be manufactured from the whole cloth. If the designer provides documentation of the efficiency of his design, it'll come from calculations or computer models that provide wide latitude for fudging. So here's a legal question for you. Does misrepresentation of the efficiency of a building design constitute fraud? In commercial buildings, the impetus for efficient building design began with ASHRAE Standard 90, which you see here, the first U.S. national standard for energy efficiency in buildings, and still the most common and the standard that underlies most other standards. ASHRAE stands for the American Society of Heating, Refrigerating, and Air Conditioning Engineers, which is the organization that led the charge on improving energy efficiency in building and is still, to a very large extent, a major player. On the left is the first draft of Standard 90, which was released in 1977. There have been many revisions of Standard 90, and they keep coming. On the right is the 2004 version, which was released just after I served a 3-year stint on the Standard 90 committee. Since ASHRAE Standard 90 first appeared, there have been other energy efficiency codes and standards. Some disappeared after a period of popularity, and some others have gained considerable attention. We'll discuss energy efficiency codes and standards further in the second webinar on Thursday. But for now, here's a key conclusion for attorneys. For the last 40 years, building designers should have been fully aware of the centrality of energy efficiency in building design and construction. For buildings designed before the mid-1970s, energy waste was largely the result of a general lack of interest or awareness. But since that time, older buildings should have been upgraded to improve their efficiency. For example, a type of HVAC system called constant volume reheat was common before 1973. It was very comfortable, but it was extremely wasteful. Virtually all of those systems should have been modified to a different type that is more efficient, and indeed, shortly after 1973, most of them were converted to something else, but not all of them. Moving on, the next area of damages to consider is health hazards. Unlike energy efficiency, health hazards in buildings have been a concern since the first large steel frame buildings were built in the late 1800s. They originated in Chicago, by the way. At that time, there was a concern about the spread of disease in large buildings because it was recognized that many people would be in close contact, and there was a great concern about epidemics. So, as a result, central ventilation systems were installed in modern buildings from the outset. These centralized systems soon evolved into central heating and cooling systems, but these in turn created health hazards of their own, which were recognized only later and which we're still dealing with today. Disease is especially associated with cooling systems and with the use of ducts to distribute air, and these continue to be areas of concern also, or specifically. In the modern era, public awareness that buildings can pose health hazards began with the outbreak of Legionnaire's disease in Philadelphia in 1976 in the Bellevue Stratford Hotel. Now note that that happened in 1976, which was almost exactly the same time that concern about building energy efficiency arose. As a result, there was a tendency of these two issues to be conflated in the minds of a lot of people, and they were conflated incorrectly. The cause of the Legionella outbreak was the growth of dangerous bacteria, which are now called Legionella, in the water of the cooling tower for the air conditioning system. The spray from the cooling tower was falling on top of a large rectangular duct that provided ventilation air to the entire hotel. The top of the duct was flat, and it had joints, so the contaminated water leaked into the air supply, thereby killing and sickening a large fraction of the occupants. I remember that history particularly because only a few years later, I was doing a survey of a famous hotel in New Orleans, and I found what appeared to be a similar situation. So I called the Centers for Disease Control in Atlanta, and somewhat to my surprise, I was immediately put through to the researcher who had led the investigation of Legionnaire's disease initially. He gave me a briefing about what was known at the time, and I then contacted the general manager of the hotel. We worked out a solution, and the situation was corrected immediately within a few days, which goes to show when you have motivation, things can happen quickly. The Legionnaire's disease outbreak quickly established so-called sick building syndrome as a more general design issue, including other hazards such as mold and organic vapors. The majority of building health hazards are related to the HVAC design. In particular, ducts are notorious breeding sites for microorganisms because they accumulate dirt that is food for bad bugs. Toxins and pathogens may be distributed throughout a building by improperly designed ducts, and you'll notice in the course of this discussion, we keep coming back to ducts. I recall a building for a pharmaceutical research organization in which the fumes from the laboratory side of the building are passed through the ducts into the offices on the administrative side, which is an example of dangerously defective HVAC design. Improper ventilation design can increase carbon dioxide levels and the levels of some other irritants, causing headaches and making the occupants groggy. Improperly designed outside air intakes can cause serious problems. A design mistake that I've seen repeatedly is placing the outside air intake for a building in a pit below grade. In one building with which I'm familiar every time fertilizer or herbicide is applied to the foliage outside the building, these chemicals permeate the building, causing distress to the occupants. Recirculation of building exhaust air can be dangerous. There's a famous research facility where I was called to do an energy study, and in the course of doing that, I discovered that the exhaust from the laboratory fume hoods, where they were dealing with diseases for which there is no known cure, was falling from the roof on warm days. That was because the exhaust was at room temperature, which was cooler than the air outside, so it was denser, and it fell to the ground in the absence of wind. The exhaust was then re-entering the building through a central outside air intake that was located inside a basement-level truck dock. And as if that wasn't enough, diesel trucks would idle at the truck dock for long periods, injecting diesel exhaust fumes into the building. This would be a lampoon of bad engineering if it weren't real. Health hazards can also arise from architectural and interior decoration mistakes, such as installing impermeable wall coverings in humid climates. There's a picture in my recent book, Superhouse, that shows a nasty example. What happens is that moisture penetrates through the wall from the humid conditions outside, but the moisture is trapped behind the vinyl wall covering, where it creates a breeding site for mold that contaminates the interior of the building. In addition, hazardous microorganisms may proliferate in hot water storage tanks. This is a plumbing design issue, and that has been particularly hazardous in hospitals where the patients have reduced resistance to infection. Also, the building operators can create health hazards, usually by lack of maintenance. For example, by failing to keep air filters clean or failing to treat cooling tower water properly, which, as we saw, led to or can lead to Legionnaire's disease and similar diseases. Litigation involving health hazards in buildings typically requires two experts. One is an industrial hygienist who tests for and analyzes the pathogens under his microscope. The other is an engineer who determines the conditions that created the environment in which the pathogens could grow and disperse. The next category of damages that arises in buildings is discomfort, which is related to impaired productivity and occupant complaints. Typical complaints are uncomfortable temperatures, uncomfortable airflow. Too little airflow results in complaints that the air is stagnant. Too much airflow results in complaints of drafts. You have complaints of noise, which come back to ducts, typically, which are great transmitters of noise of the fans and other air conditioning equipment. Odors also transmitted through improper duct design. Eye strain from interior lighting, and eye strain from solar glare. The primary causes are deficiencies in the architectural design, as in solar glare and discomfort near the walls of the building, the HVAC design, HVAC installation, and HVAC operation, which is responsible for a majority of health problems, noise and odors, and the lighting design. In litigation, occupant complaints that are not clinically demonstrable are contentious and so likely to lead to difficult litigation. For example, the plaintiff will assert that most of the occupants are suffering from headaches and lassitude caused by conditions in the building. The defense will claim that the symptoms are mass hysteria that is being created by the plaintiff. So if the cause or causes can't be confirmed with blood tests or other medical evidence, at least provide good documentation of the complaints. And your experts should be able to find credible physical causes of the complaints, such as insufficient ventilation air, the presence of toxic mold or VOCs, again that's volatile organic compounds, or other factors. At this point, we're halfway through our discussion of damages, so maybe we want to take a breather and pause for comments and questions, if there are any.
Thanks, Don. If everyone could type in the passcode in the Q&A widget, that'd be great. The first question is, if energy costs are the sleeping giants of litigation, how will the giant be awakened?
Well, attorneys have to make the owners or the parties who pay the energy bills aware of their damages. And it's kind of ironic this hasn't already occurred. We have a second home in Florida, and every other billboard along the highway is an advertisement by an attorney for some form of complaint, such as medical malpractice, very commonly automobile accidents, and so forth. But that same level of awareness isn't occurring on the part of the victims of high energy bills. And what makes that particularly ironic is that a majority of commercial building owners and operators belong to just three organizations. BOMA, which is the Building Office Owners and Managers Association, IFMA, which is the International Facility Managers Association, and AOBA, which is the Association of Office Building something or other. So you have probably a majority of people paying the energy bills clustered in these three organizations, and they're very interactive. They talk to each other. So I think if the attorneys would get in touch with those people, then I think that we would start to see litigation in this area break loose.
Okay, how common are health hazards in buildings?
Very common. Most buildings, well, I won't say most buildings, but they're very common. Now, what varies is the intensity. They may go from very latent conditions to severe conditions. Milder health hazards tend not to be traceable to the building. For example, someone has asthma, doesn't know why, doesn't suspect that it comes from mold growth that's occurring in the building until perhaps the person goes away on a 2-week vacation and then says, oh, gee, all my asthma has cleared up. But they still don't know it's come from the building where they work. It might be from home. It might be from the grocery store where they shop, what have you. On the other hand, very severe health hazards are more readily traceable to the building.
Okay, are energy cases common for homeowners?
It varies. Homes tend to, the energy efficiency of homes, residential buildings, unlike commercial buildings, has been improving. So that what you have today is that the average level of efficiency in homes is better, considerably better than the average level of efficiency in commercial buildings. You do still have severe sources of energy waste, and the largest one of those is central heating and central cooling, which is very inefficient because you live in one room at a time. You don't live in the entire house. There are systems now that can individually control individual rooms very comfortably and very efficiently, but they are still a minority in homes. The big question is liability. I think that liability can be determined a lot more easily in commercial buildings than they can in homes. I think probably we ought to be pushing on.
Yes, feel free to go on. Thank you.
Okay, thank you. Let's continue with the next category of damages, which is wasted capital expenditures. We can start with excessive cost for HVAC equipment. These are the boilers, chillers, fans, pumps, ducts that are needed to satisfy the energy appetite of the building. The fault may be the architectural design. The architect designs a glass facade because it's cheap and easy to design or fashionable, but the cheap facade increases the energy requirement of the building, which in turn increases the cost of the HVAC equipment. Or the fault may be inefficient or extravagant design by the HVAC engineers. I did an analysis years ago of a well-known children's hospital in which the design of the HVAC system almost doubled the floor space requirement of the hospital with no significant benefit to the hospital. The hospital had been designed by an architect-engineer firm with a reputation for extravagant design, and I think the reason they got away with that And the higher design fees is that in those days hospitals were being heavily subsidized, and it was a children's hospital, so they were getting a lot of donations, so they got away with designing what was a terrible energy hog in addition to being a waste of floor space. Another type of wasted expenditure is for immature and unproven technology. Geothermal heat pumps are a common contemporary example. Typically the expenditure for any kind of immature technology occurs because a designer recommends it to the client. This is usually an engineer. Recommends it to the client without giving responsible consideration to the shortcomings of the technology. In other words, the engineer is using the client as a guinea pig. We see too much of that. Then we have rapid obsolescence as another waste of capital. For example, I commonly found central computer energy management systems to be abandoned either because they weren't installed properly or they just become obsolete. So a legal question for the attorney is the extent to which early obsolescence is predictable or justifiable. The cost of equipment for lost utility incentives may be a big loss. What happens is that the electric utility companies are faced with the cost of building new generating plants. To avoid that, utility companies have encouraged their customers to install equipment that levels the utility company's load, and in return, the utility offers discounted rates. The two most expensive and common examples are thermal storage systems and cogeneration systems, and they very commonly fail, either because the equipment is not adequately evolved or because it requires operating skills that are beyond the capacity of the facility staff. So this leaves the owner with a lot of expensive junk. Another trap is that the utility company typically withholds the incentive if the customer fails to maintain continuous operation of the system, even for a short period of time. So a 5-minute interruption in the customer's equipment could vacate the discount for months or perhaps even for an entire year. Or the utility company may just unilaterally withdraw the incentive after a period of time. So if you're dealing with lost utility incentives, get an expert to read the contract to see whether there was a guarantee of continued incentives or a forgiveness clause for brief lapses. Also, utility deregulation has thrown a further complication into this, and we may talk about that in the session on Thursday. Bogus technology is always out there, and it changes continually. For example, I was called to evaluate a system claiming that water is a fuel. This system was actually a heat pump that extracted water from the home swimming pool for a short period of time until the pool froze. I have encountered other bogus items over the years, such as a chimney cap that was supposed to improve boiler efficiency by 40%, which was, of course, completely impossible. Surge suppressors were popular for a while, making false claims of improving motor efficiency. And fluorescent fixture reflectors were a very successful scam for a number of years. It was so successful it was even being promoted and subsidized by various government agencies. It's usually easy for the expert to debunk such snake oil, but the vendors are likely to vanish before litigation can recover the cost. So it's far better for the building owner to avoid buying alleged technology that they don't understand. Incorrect energy billings are surprisingly common, especially where sub-metering is involved. Typical example is a large building that is sold because the original owner moves the activity to China. The new owner buys the buildings cheap, subdivides the space, and rents it to several tenants. The original electrical circuits and the gas distribution pipes were not laid out to enable individual energy metering of the newly created tenant spaces. So in the absence of sub-metering, the owner allocates the energy cost to the tenants in some manner, which typically doesn't accurately reflect the actual energy consumption of the individual tenants. So some tenants are paying for energy that's used by other tenants. For example, I was involved in a case where a clothing manufacturer required close control of temperature and humidity in his rental space, and the other tenants needed only minimal HVAC. A dispute eventually arose. Litigation resulted, and a lot of analysis was required to achieve a reasonable resolution. Another waste of energy cost may occur if the electric or gas utility company is providing service under a rate schedule that is unfavorable to the customer. Especially for larger commercial customers, utilities may offer a variety of rate schedules, some with different demand charges, some for different rates for different times of day, some that allow for interruption of service under certain conditions. Now, a facility may operate for years or decades until someone finally questions the rate schedule, at which time the question arises who pays for all that wasted money. However, beware of complaining to the utility company about the customer's rate schedule until your expert has examined all the options. This can cut both ways. It's entirely possible that the customer may have been assigned an especially favorable rate schedule, and the utility, when challenged, may decide that the customer is not eligible for such favorable terms. So be careful before you go there. This category of damages, latent physical hazards, is different from the previous damages in that overt harm has not yet occurred. These damages are potential. For example, if the HVAC system has defects that would allow the spread of fire and smoke through the ducts, even if the building has not had a fire, or it may never have a fire, are there damages? So the legal question is, when do latent damages become actionable? I know there is some discussion in the law about this, but you're the attorneys, I'm not, so I'll leave it to you to be aware of that question. Typically, latent physical risks are caused by the design or installation of the HVAC system. That's where the fault almost always lies. Significant risks include fire safety defects. For example, the ducts of central HVAC systems are a path for the spread of fire and smoke during a building fire. That's well known. So to prevent this, ducts have dampers that are supposed to close automatically when a fire occurs. But I have repeatedly looked inside ducts and seen that the fire dampers are partially stuck in a partially closed position. So they impede airflow all the time, which interferes with comfort, while not being able to close fully in the event of a fire. Another case is so-called active fire protection systems involving control of the HVAC system fans to clear out smoke during a fire. These schemes are vulnerable to failure, as was demonstrated recently in the Washington, D.C. subway, where ventilation fans were operated incorrectly, resulting in the deaths of passengers on a stalled train. That was about a month or two ago. Then asphyxiation can occur from the release of large volumes of refrigerant gas into interior spaces, which displaces the oxygen that the occupants need for breathing. There is a popular new type of central heat pump system that is greatly increasing the possibility of this hazard. Finally, I don't want to provide a tutorial for any terrorists who may have enrolled for this session, but some buildings are much more vulnerable to terrorism than others. So the building owner needs to be sure that his building has the maximum protection against that modern hazard. And finally, all of the previous deficiencies contribute to devaluation of the property. Defects in the building must be repaired or mitigated at some point, and that will involve a tangible cost. Some deficiencies can reduce the rental value of the facility. For example, the architectural or HVAC design may take up excessive rentable space, and air conditioning systems that are less comfortable may reduce the rentable value. If a building is going to be sold, the potential buyer who exercises due diligence is going to discover defects, even if the owner is unaware of them. For example, the potential buyer will discover excessive energy costs by examining past energy bills, and if he finds that, it's going to reduce the sale price. And significant comfort or health problems may make the building completely unsaleable. Okay, we're done with damages. That was a lot of information, but the attorney doesn't need to get mired in the technical details. Instead, use the previous summary to make sure that your experts cover all of these issues adequately. Now let's move on to the next litigation issue, which is who is harmed. In other words, who are the potential plaintiffs? And these are the commonly injured parties: the owner, the occupants, other property owners, and design and construction practitioners. The owner is harmed by excessive energy costs, devaluation of the property, wasted capital expenditures, liability to the occupants, and typically what happens, or what may happen, is that even though the owner is the one ultimately harmed, it's the occupants who first make the complaint, and they may sue the owner. Then the owner has to turn around and sue the people who are responsible. And the owner is harmed by liability to other property owners. The occupants are harmed by health hazards, physical dangers, discomfort, and reduced productivity, all of which we have already discussed. Other property owners may be harmed in a variety of ways, such as reflection of solar glare and heat. This is an issue that came up with the introduction of glass box buildings. The glass wall of a building acts as a huge mirror, and it can focus heat and glare on the building next door, and there have already been a number of cases about this subject. Then we have the problem of emission of noxious exhaust. So if a laboratory building is next door to another building, there may be a health hazard that is involved there. And there are various other ways in which one building can harm another. And then we have design and construction practitioners being harmed, and they're harmed by liability to everybody. Liability to the owner, if they get sued by the owner, liability to the occupants. If they get sued by the occupants, liability to other designers. For example, if the structural engineer makes a mistake, he may be sued by the architect, who in turn would have been sued by the owner. You have liability of subcontractors to contractors, and you have loss of payment, which commonly results to practitioners where there's a dispute. So these are reasons why designers and builders carry expensive liability insurance. I think that's all that we have time for today. Next time, we will cover who's at fault, that is to say, who are the potential defendants, the challenges of litigation in this particular evolving area of litigation, how to select your experts, which can be a little bit tricky, and we will conclude with comments and recommendations. So now I see that we still have time for more comments and more questions, and we'll welcome those.
Great. Thanks, Don. If everyone could type in the passcode into the Q&A widget, that'd be great. The first question is, what types of buildings have the most excessive energy costs?
Buildings with lots of glass. That's true of modern buildings. The glass building is a horrible energy waster for the very simple reason that glass has very little insulation value if you want to be able to actually look through it. And in the summertime, glass is where all of the air conditioning, or a large fraction of the air conditioning load, comes from. Older buildings, you would think that older buildings would be less efficient than modern ones, but it turns out that that's not true. I had mentioned that back in the late 70s, I was doing some volunteer work for ASHRAE, in which we were collecting all the energy data we could on buildings, and we were surprised to see that actually the older buildings were more efficient than the newer buildings. Now that was in terms, when I say efficient, I mean in terms of energy cost. Now, they weren't as comfortable, but your most efficient building back in those days was a building that had steam radiators and window air conditioners, even though the windows might be terribly leaky and otherwise not very efficiently made. So it's a function of the type of building and I would say the most expensive would be office buildings, medical buildings, because they're open 24 hours a day, and I'll leave it at that.
How can you determine whether the energy costs of a building are excessive?
Well, the definitive way to do that is to do a detailed analysis of the design of the building and of the physical condition of the building itself. That takes time and money, but that's definitive. What you'll do is you'll compare each aspect of the building's design to a baseline of what the efficiency level should be, and then you subtract A from B and you get C, where C is the excessive energy cost. Now, as I say, that's expensive. That's expensive for the client who's paying the bills. A good initial screen is to look at how the energy costs of the building per square foot compare with the energy cost per square foot of similar buildings. And we do have data on that. It's not good data, it's not reliable data, but we have it. And the most common comes from a database produced by the Department of Energy called CBECS, which is CBECS, and I don't know what that stands for. But it's a database of buildings that's broken down by age, size, type, and other characteristics. And it gives you, as I say, dollar cost per square foot for different types of energy. Now, bear in mind that buildings today are a bad lot. So your building may be wasting a lot of energy, even though it doesn't appear to be in too bad a shape relative to other building types. It's just the best of a bad lot.
For what period of time can the owner seek redress for excessive energy costs?
Okay, I think what you mean is, let's say you've got a building that's 30 years old, and the owner finally gets around to realizing that his energy costs are a lot higher than they should be. And so the owner goes to seek redress from somebody, and he determines that the cause of the excessive energy cost is largely that the building wasn't designed right in the first place. And 30 years ago, it should have been, because designers at that time already knew about energy efficiency. So the question that you're asking is, does the owner get to collect for all the excess costs going back 30 years? Or will the defense be that, well, the owner should have figured out sooner that he was spending more than he should have been spending? And that is a question that is more of a legal question than one that an expert witness can answer. So that is something for the attorneys to argue in litigation.
What accounts for the 5-to-1 ratio in building energy costs?
Yeah, well, that's a question that we looked at real hard back when we first encountered that enormous ratio. It had a lot to do with the type of HVAC system in the building. As I mentioned before, we found, to our surprise, that the older buildings that had steam radiators and window air conditioners were actually operating with lower energy cost than the newer ones. And the difference primarily was that the HVAC designs that engineers had come up with, starting in the late 1960s, were very extravagant energy wasters. And I mentioned the constant volume reheat system. So if you compared two buildings, one with window air conditioners and the other one with a constant volume reheat system, that would account for your 5-to-1 difference. Now, then starting after the energy crisis in 1973, they started looking for substitute comfortable air conditioning systems, and basically they didn't find them for the longest time. So you had systems that were less wasteful, but also less comfortable. And not to get too much into the technical details, the central systems at that time were then replaced by what are today called VAV, or variable air volume systems. And everyone thought that that was going to be the panacea that would take care of the problem, and it turned out that that was a false hope. The VAV systems are not very comfortable. They have some fundamental problems in comfort, and they're not fundamentally as efficient as everyone had hoped. So we are still looking for the ideal system. I think we found it. We have, I think, starting in around 2005, we've defined a very good kind of HVAC system, but it has not yet gotten into the mainstream of building HVAC design. And the other factor in the 5-to-1 difference, looking at newer buildings, of course, is glass. A glass box building performing the same function as a building next door with a reasonable amount of glass may have a 5-to-1 difference in energy cost for that reason alone.
If a building owner has spent a substantial amount of money for equipment to qualify for a rate incentive and the utility discontinues the rate incentive, what recourse is available?
Again, that becomes a legal question. And you start by reading the contract between the utility company and the customer. And you hope that when you read that contract, you will see the terms and conditions under which the utility company is obliged to maintain the incentive. Unfortunately, I have looked at such contracts, and they don't contain a guarantee of continued operation of the incentive. And I fault the owner's attorney for agreeing to such a thing, if the owner's attorney even was involved or called in on it. I fault the engineer who recommended that system to the owner. And there is a further muddling of the issue, which is utility deregulation. It used to be that your local utility company owned the generation plant, owned the power lines, and thus had total control of the load profile. And again, modifying and leveling the load profile is what this is all about. Well, utility deregulation came along and essentially seized the power lines, making them a common carrier, so that the utility no longer has control of its own load profile, and as a result of that, no longer has an incentive to continue the rate incentive to the customer for load leveling. So that really gets into a more complex legal issue, is as to whether the government is liable for having left the utility company holding the bag, and the utility customers holding the bag. That'll be argued.
Okay. How much difference is there between commercial and residential cases?
A lot. Your residential houses, as we have discovered, don't have the blatant kind of energy waste that you see in commercial buildings. The damages are much smaller because houses are a lot smaller. And now, I have, as I mentioned, I have seen some cases of snake oil in residential houses. The case where one company was claiming that the water in the homeowner's swimming pool could be used as a fuel, and we debunked that, and we got recovery on damages there. But, it wasn't a huge dollar amount. And the other difference between the residential and the commercial sectors is that the people involved are different. The designs are much simpler. The infrastructure is different and simpler, and the equipment is different. So it's basically a much more limited range of damages and on a smaller scale.
Okay, last question. What are the common causes of discomfort and impaired productivity?
Lots of them. If you have thermal discomfort, meaning it's too hot or too cold. In fact, I think we even had a slide on this. And you have airflow problems, either too much or too little. you have noise coming through the ducts because of the HVAC system, or perhaps because of inadequate interior design by the architect, preventing noise going from one office to another or from the machine shop into the offices, and so forth. I think if we go back to that slide, we'll see most of the causes listed.
All right, thanks, Don.
Thank you.
In addition to being your best source for testifying and consulting experts for the past 60 years, TASA also offers e-discovery and forensic solutions, free interactive webinars, cybersecurity services, analyze videos, in addition to research reports on expert witnesses, the Challenge History Report 2.0, the Preliminary Screening Report, and the Expert Profile 360. I want to take this opportunity to thank everyone for attending, and most especially Donald Wulfinghoff for his time and effort in creating this presentation. If you would like to speak with Donald, or if you would like to speak with a TASA representative regarding an expert witness for a case that you are working on, please contact TASA at 1-800-523-2319. Deb Mars was actually sitting into the program today, and she will give everyone on the webinar a follow-up call. This concludes part one of Mr. Wulfinghoff's presentation, and we will resume on Thursday at 2 o'clock. Thank you.